Dear students, today we are going to learn series circuits. Let's see what is meant by a series circuit. Suppose in a circuit, if the elements are connected end to end so that there is only one path for the current to flow, then the circuit is called series circuit. Let us consider three resistances R1, R2, R3. Here, as per our definition, we need to connect these elements end to end. So R1, one end is connected to R2 and R2 is connected to R3 such that there is only one path for the current to flow. Suppose if this combination is supplied from a voltage source of V volts, as the path is closed now, circuit is closed, then a current I amperes will flow in the circuit. For this current I amperes to flow in the circuit, that means to the connection of R1, R2 and R3, there is only one path. So the same current is going to flow through the resistance R1, R2 and R3. As there is only one path for the current to flow, this type of circuit is called as series circuit. Now let us find out the equivalent resistances when the resistances are connected in series. Let us assume the resistance R1, R2, R3 are connected in series. R1, R2, R3 are connected series, and the series combination is fed from a voltage source of V volts, and it is causing a current of I amperes to flow in the series combination. Now its equivalent circuit is taken as same voltage source V volts is applied here, plus V, and for the same current I amperes to flow in this circuit, the amount of resistance that we need to connect, I am taking as RS. So RS represents the equivalent resistance of R1, R2, R3 series combination. So this RS is replacing the series combination of R1, R2 and R3, so that the circuit properties have not changed. So what is the value of RS that we need to connect in order that the properties of the circuit should not change? So when you apply V volts, the current should flow in the circuit is I amperes. So what is the value of RS? That is the equivalent resistance that we need to connect in order to replace this R1, R2 and R3. So the equivalent resistance can be calculated as follows. Now here the voltage drop across R1 I am taking as V1 volts, and across R2 as V2 volts, across R3 as V3 volts. Then V1 is given by using Ohm's law. The current flowing through the resistance is I amperes and the resistance is R1. So V1 equal to I R1, V2 equal to I R2 and V3 equal to I R3. Now from Kirchhoff's voltage law, here the total voltage applied is V, which is equal to the sum of voltage drops V1 plus V2 plus V3. So V equal to V1 is IR1 plus IR2 plus IR3. So by taking I as common, we will get R1 plus R2 plus R3. So is the expression for V. Let it be equation 1. From this equivalent circuit, here the voltage applied is V and the current flowing through the resistance is I and the resistance value is Rs. So V equal to IRs. So for the circuit properties should be same. From the equation 1 and 2, IRs should be equal to I into R1 plus R2 plus R3. So these are from equation 1 and equation 2. So by cancelling I and I, we will get Rs equal to R1 plus R2 plus R3. So the equivalent resistance of the series combination, when three resistances are connected in series is given by Rs equal to R1 plus R2 plus R3. Suppose if you connect n number of resistances in series, then the equivalent resistance is given by R1 plus R2 plus R3 plus so on Rn. Okay. So the generalized formula can be written as Rs equal to sigma I equal to 1 to n Ri. So if we have connected three resistances in series, then n equal to 3. So the equation will become R1 plus R2 plus R3. If you connected 5 resistances, then R1 plus R2 plus R3 plus R4 plus R5. Okay, like that you can find out the equivalent resistance. What are the properties of a series circuit or characteristics of a series circuit? First one is the current through all elements is same. The current through all elements are resistances. Generally we are going to connect resistors in series circuits for DC circuits. So the current through all resistors is same and the voltage drop across individual resistances is different and the equivalent resistance or total series resistance is given by sum of individual resistances. Okay. Sum of individual resistances that are connected in series, and the total power consumed by the individual resistors is equal to the power delivered by the source. So whatever the power delivered by the source, that entire power is going to be consumed by the all the individual resistances. So sum of all individual power consumptions in individual resistances is equal to the total power delivered by the source. These are the characteristics of series circuit. Thank you.